So, you want to build a nuke, huh? Well, first you'll need to mine some uranium. This is a radioactive element that has many uses, like generating electricity, curing cancer, or destroying the entire planet. Anyway, once you've dug out the uranium, it needs to go through a series of chemical steps to prepare it for enrichment. Why? Because raw uranium ore is mixed with a bunch of other non-explosive stuff, which is rather useless unless you're looking to adopt a pet rock to slowly kill you with radiation poisoning. But obviously, you don't want that. You're just an innocent ape looking to destroy all of humanity. So instead of that, dump the ore into a mill that crushes it up to make what's called yellow cake. Oh, you might not want to sniff that. Now dissolve that yellow cake in nitric acid to make uranyl nitride. Heat that to produce triuranium octoxide. Throw that into this reactor where it's heated and reacted with hydrogen fluoride gas. This will give you an ice cream powder called uranium tetrafluoride. Then heat it again, this time with pure fluoride gas, and bam! You got UF6. This is a special compound that has to be stored safely and handled with extreme care. Even the tiniest leak from this beautiful container could burn your lungs and cause you extreme suffering for the rest of your life. Anyway, throw that shit into one of these massive centrifuge and try not to hop in. And inside the centrifuge, the gas gets spun at absurd speeds. This separates the lighter uranium-235 isotopes from the heavier uranium-238 ones. And that'll give us enough U-235 to sustain a chain reaction. This is exactly the kind of reaction we need to make the bomb go boom. Now take your freshly enriched UF6 gas and cool it down to turn it back into solid uranium metal. Now it just needs to be purified, and congratulations, you got yourself some smoking hot weapon grade uranium. But how do you actually make this thing explode? Well, to figure that out, we need to talk about fission. Fission is when you hit an atom. That atom splits into two smaller atoms, which spits out more neutrons and releases a lot of energy. If enough of those neutrons hit other uranium atoms, you get a runaway chain reaction. Like dominoes, except every domino releases the energy of TNT and a cancer diagnosis. But for that chain reaction to actually happen, and happen fast enough, you need supercritical mass. That means cramming enough enriched uranium together in the right shape and density so the neutrons don't escape. You do this by surrounding the uranium core with explosives. When detonated, those explosives don't blow the core apart. They compress it inwards with staggering force. The atoms are squeezed so tightly together that the whole thing tips into a supercritical state, and at that point physics basically has a nervous breakdown. The temperature in the core spikes to millions of degrees in a fraction of a second. You get a blinding flash of light, a shockwave faster than sound, and a fireball so hot it turns solid buildings into mere vaporized suggestions. And just like that, you've taken a chunk of metal and turned it into a sun. Briefly, before everything around it ceased to exist. But not all nukes are the same. In 1945, Japan was hit with 2 atomic bombs. First, a bomb called Little Boy was dropped on Hiroshima on August the 6th. Only 3 days later, the bomb Fat Man followed over Nagasaki. Together, they killed hundreds of thousands of people. Fat Man alone had an explosive force of about 21,000 tons of TNT. The destruction was so total, so absolute, that it left the world in shock. Scientists warned about ever using these weapons again, citizens protested, and the world leaders talked about wanting peace. So of course, we immediately started building something even worse. Introducing the fusion bomb. Now, if a fine gentleman, such as yourself, wasn't enticed by the offer of a regular old nuke, well, good news. This new and improved hydrogen bomb is about 2,000 times stronger than that silly old little Fat Man. Now, to understand why it's so much more powerful, let's talk a bit about fusion, eh? If fission is tearing atoms apart to release energy, fusion is smashing them together. Specifically, you take light atoms and force them to fuse into heavier atoms. That fusion releases even more energy than fission, and not by a little. But those hydrogen atoms don't fuse easily. You need temperatures of tens of millions of degrees, and the only way to get that is to blow up a fission bomb first. Yes, we literally need to use an entire fucking nuke as a lightning match for one of these bad boys. So a fusion bomb is basically a nuke with a nuke inside it. Once a fusion bomb ignites, you're not just flattening buildings, you're rewriting geography. Yields jump from 15 kilotons to 10, 20, even 50 megatons. That's the equivalent of millions of tons of TNT. And that's why today we live under the shadow of mutually assured destruction. If you nuke your enemy, and they have nukes too, they will nuke you right back. Whoever fires first, dies second. Anyway, if you do decide to ignite a nuke, well then you're probably in for a bad time. Even if you do win the battle, you've already lost the war.